Derek teaches Minitab Lesson 2. In this lesson, we're going to do something more intermediate than we did last time. We're going to make use of Minitab and try and do some predictive analysis. And what does predictive analysis mean? Well, the idea is that you're using a statistical calculation and historical data to try and develop a way of predicting the future. Let's open Minitab and get started. Okay, we've returned to Minitab. If you remember last time, the session is where the output comes in from any sort of calculation analysis that we do, and the bottom is the worksheet where we keep our data. Instead of hand typing the data, what we're going to do is we're going to open it from an Excel spreadsheet. So open worksheet. All of these are Minitab projects from this came with the software that we can use with analysis, but this time what I want to do is go into my thumb drive and find an Excel spreadsheet. School data is the name of the spreadsheet, so I'm going to open it. But then you'll notice that something wrong has happened. The column labels, the text that is used to tag the columns of data, they contain some of the actual data, which is not what we want. So let's delete this worksheet. A new worksheet will open. Go back, open File, open the worksheet again. Click on School Data, and this time go to Options. Variable names set to none. We don't want to automatically set up variable names. First row of data is automatic. Now I just happen to know that there's 60 points of data, 60 samples. Once you have all those set, click OK. Select School Data and click Open. Then you'll notice that the data is in its proper place, and then we can set up some label names of observations. This is high school GPA, HS-GPA. This is IQ, gender, and this is year 1 average test score, average tests, college average, first year college average. So all 60 observations are students. The GPA is their high school score, and year 1 college average is basically their overall year test score after their first year of college. We want to know if we can predict how well a student will do in their first year of college based on their previous high school GPA. And so looking at these two columns of data, the first thing that we can do is just do a scatter plot and look for ourselves with our eyes before doing any major calculation whether or not there is any sort of relationship. So what you can do is go to Graph, Scatter Plot, Simple, OK, and we want our Y. Our Y is usually the output or what we want to predict. So that should be year 1 college average. And then the X variable is the input, which is high school GPA. Click OK. And here's our scatter plot. You notice that there's a relationship immediately after doing the scatter plot of all 60 students. There are no plots that are in the extreme areas where GPA is low and the average college test score is high, and vice versa. There appears to be a centering of the data through the diagonal line of the graph, which indicates that there's some sort of relationship between GPA and first year average college test score. So right away we can move forward and see if this fits within some sort of linear relationship. So what we can do next is we can do a regression analysis. And regression analysis, what it does is it calculates a formula in which we can predict. We can use the formula going forward to predict first year college average scores based on a high school GPA. Let's go to statistic regression. And so the response is year one college average, because this is going forward, this is the output that we want from our prediction method. And then our predictors are high school GPA. Click OK. And open up the session window all the way. And immediately we have a formula. So basically, we can take, if this formula has a good fit, we can take any GPA from any student, plug it into here, and we can predict more or less how they're going to do in college. We can identify, with this formula, we can identify students that might have issues before they enter college and see if we can work on them. So this is where the math becomes, Minitab becomes very useful. So think about your career. Think about defect, you're analyzing cars, the manufacturing of cars. You have a defect rate, and then you have a sales success. So if you're looking at different models of cars in your automobiles, in your business, you could plug in defect rate and see how well they'll sell. Or maybe not defect rate, maybe it's something else related to that automobile or that product, and you can predict sales. But we don't know how good this formula is. How accurate is it? So a lot of these other statistics, and then once you go through a Minitab textbook or some sort of lesson plan that you might find online, you can use all of these other calculations to predict the kind of fitness that you want. But right now, immediately, what you can do is just look at the R-squared calculation. Because what this calculation is saying is that of all 60 observations, 76% of all the observations fit very well within this formula. Whereas the outliers, which are 76, so 1 minus 0.076. Let me find the good old calculator. Calculator. No. But basically, it's 24. So there's 24% of the remaining data doesn't fit within this using this formula. So 24 of the observations, the history used to create this regression, they can't be explained by it. So you can, based on a set rule or whatever predictor, maybe 76% R squared fitness is good enough for this calculation. Good enough for the data, and good enough to use the formula for whatever purpose you need to. But in order to do a real fitness test, we're going to want to graph various concepts, various degrees of measure based on fitness, on the sum of squares, because Everything about regression is based on collecting and comparing sum of squares calculations. And we can do that through the same regression methods used to create the basic regression formula that we have. So if we go back to stat and then regression, click on regression again, and then this time we want to click on graphs. You can see here there are a number of graph options that we can use in order to graph the residuals and understand the fitness of the sum of squares. So click on 4 and 1 because we want to do all 4. Yep, we want to keep the response and the predictors. Click OK. And then we can see here the residuals, how well they fit onto the actual formula. You can see there's an outlier here. We can also graph the residuals and see how they fit and whether or not they form a bell curve. You can see here the bell is slightly skewed to the left. And then you can look at observations in something that looks like a control chart method. So that is regression analysis in a nutshell, without going too deep into some of the deeper meanings and deeper uses. So I hope you enjoyed this lesson. I'll talk to you soon.